let's look at example 2 from R8. They're giving you, this time, data that includes a rate. All right, so you have a rate function. And often they'll have you do stuff with that, and then they'll ask you to do, it says sometimes you're given, and then you're given a model for the function. So you're given the data and then a model, and that kind of is how you're supposed to compare the two or whatever. So that's what this one does. So part 1, let's just read what it says. The rate at which water flows into a tank, so it's going into the tank in gallons per hour, so there's the unit, gallons per hour, is given by positive continuous function r of t. The example, the table shows the rate at selected times. So it says use a midpoint Riemann sum with 3 subintervals to approximate r 0 to 12 of rt dt and explain the meaning of the definite integral. Okay, so let's just do that first. So 0 to 12 r of t dt is, going backwards, if you were given a rate and take the integral, it's just going to give you gallons. So, and it's the gallons over this number right here, 12 hours. So that is the total number of gallons flowing into the tank from 0 to 12 hours. All right, so that's you explaining what that means. Now we have to actually calculate a midpoint Riemann sum. 3 subintervals. So when they give us this, it's nice because you have the numbers already, no calculation. So you're going to have a middle point here. So there's your first one. And these are 4 apart each time, which makes things easier. So this is 4. And you're going to use that midpoint. And then 4 to 8 is delta t is 4. You can use that number, and 4, and you're going to use that number. So I kind of like midpoints. I feel like they're pretty easy. So 0 to 12 rt dt is approximately equal to, and then you just add these up, and it's not asking for any average, so you should get a total. So let's say it's 4 times 13.4 plus 4 times 14.3 plus 4 times 14.8. All right, and so if you add those numbers and multiply that out, you get approximately 170 gallons. Okay, so that's example 2, part 1. Let's go on to part 2. So now they give you a model. This was just the data, and they've given you a model for the flow into the tank. They want you to use P of T to find the, there it is, average rate of water flow during the 12-hour period. So we have to pay very close attention to the wording. So average means you would have to use your calculator and divide by 12. So you would say that the average rate of water flow is equal to 1 over 12 times 1 over 60 of 0 to 12 of 750 plus 24t minus t squared dt. And you're going to put that straight into your calculator, and you get 14.1 gallons per hour, because remember this 12, this is going to give you gallons, this stuff. And then you're dividing by 12 hours, so it's gallons per hour. All right, so that was example 2.